Um, so this, for those who were at the IWT last fall in Chesterfield, this will probably look somewhat familiar to you. But fact is, I wanted to go over it again because we had no winter last year. Really, we had that one storm in February, but that was mainly confined to our far south. And other than that, winter and snowfall was pretty minimal last year. And we'll see from Larry what we're expecting for this winter. But nonetheless, I wanted to go over this again because these are really our premier weather, winter snowfall, products for the season that you should be able to go to and get an idea of what is going into our forecast and also what we're expecting. So I'm first going to get into the probabilistic snow and why are we doing this? As many of you know, snowfall forecasting is arguably one of the most uncertain aspects that we do. But it's also one of the most important aspects of our duties, and as we know here in the Mid-Atlantic, we're always, playing with that rain snow line. When will the snow turn to sleet or freezing rain? How wet will the snow be? How cement-like will it be or fluffy? And how much precipitation will fall? All of these things go into our snowfall forecast, which makes it that much more uncertain. And again, on any given event here in the Mid-Atlantic, we're always dealing with pretty much every one of those things. So the idea of the probabilistic snow forecast is not to necessarily hedge our bets. We're still going to give our best guess to the forecast, but it will allow you to look at what we think what might be the worst case scenario for snow. Let's say the rain snow line stays off the coast or right at the coast, and we get a little bit more snow, precipitation, and the snow maybe is a little bit fluffier. And so, all those things are going, all those things go into our algorithms to figure out sort of what the worst case, scenario you could be. And it allows you to make important decisions based on that worst case. So what is the prob snow products that we do? It's a series of graphics and data that, again, will allow you to make better decisions on the range of expectations regarding storm total snowfall. And we base all this on our official storm total snowfall forecast. So we're basing it off our deterministic, our best guess for snow. And then we leverage all these numerical model forecasts, and it's not just the snow forecast from these models. It's the temperature profiles. It's the where the rain snow line is going to be from all these models, and go into and then determine what is the high end, sort of the worst case, the expected, or the most likely. Again, that would be our forecast, our official forecast, and then the low end, sort of the best case scenarios for snowfall. And then we are also creating chance of exceeding graphics and data for these various amounts, from a trace up to an inch, 2 inches, 4 inches, so on and so forth. Again, to allow you to make better decisions on what you need to do. If there are certain decision points you have for, say, 4 inches of snow, you can look at these chance of exceeding graphics, and if there's a 70% chance of exceeding 4 inches, then it's probably a pretty good chance that we're going to see more than 4 inches of snow, and you can make decisions on that. So this is sort of a science-y slide, but I think it goes in sort of dives in a little bit more of what goes into these products. So we have a most likely snowfall, our forecast, of most likely snowfall. And then we throw this into all of the models that our ensemble forecast, and we throw that into the mix, and we try to distribute the snowfall of all these different models appropriately based on our most likely forecast. And then we get these exceedance probabilities, and we get all of these, we get all the data that spits out and all the graphics and everything else. And again, there's a lot of statistics that go into this behind the scenes. Really the thing that we are focusing on still at the forecast office is this most likely scenario. And then using all the great numerical models that we have, not only in our country, but from from across the world, we're able to come up with the worst case, the various worst case, best case, and the various exceedance probabilities. So what we have ultimately for the output graphics, and again, you can find all of this on our winter webpage that I had at the beginning of this slideshow, is we have the low end amount, which again is the sort of the 9 in 10 chance that there will be snowfall at least of this amount or higher. Okay, so in this case here, this is from December of 2018, that really the last big snowfall we had across the area. You have this area here of 1 to maybe 2 inches across Mecklenburg and Lunenburg County. So what this tells you here is that you can expect, I think you can safely say that you're at least expecting 1 or 2 inches of snow down here. So this is our expected snowfall. So this is what we are actually forecasting. And again, we all know that with the December 2018 event, Richmond, and Chesterfield County and stuff, they had close to 10 inches or maybe even close to a foot in places. And this forecast was from several days before. But you can see here that this was our expected. This was actually what we were forecasting at the time. We were forecasting 6 to 8, 6 to 9 inches across the southern Virginia Piedmont, and up to 3 or 4 inches up into the Richmond metro area, and even an inch or two further east, east of 95. But then you get into and again, this is the forecast from several days before the event. But then you get into the high end amount, the 1 in 10 chance that the snowfall could be at least this amount or higher. And this is where you sort of get your worst case scenario. This is where you get, where it's, if you are having to plan for the worst case scenario, this is what you would need to look at. And again, you could see that, again, these are, you have 10, 11 inches up into the Richmond metro. You even have, 5, 6 inches, getting close to Williamsburg. And then tapering off to an inch or less towards the coast. But and again, it's the reasonable upper end snowfall amount for that time period snow. So a time period that's shown in the graphic. So again, repeating, this isn't necessarily, this isn't a hedge. Again, this is our official forecast, but given all the uncertainty that goes into snowfall forecasting, this is what we think that we are indicating could happen, especially in places. Now, I think it's important to note that this graphic makes it look like, oh my gosh, you're thinking there could be a foot or more, or 10 inches or more everywhere from I-95 east. And no, that's not necessarily true. But what we are saying is that at some point in that area, in that region could see 10 inches or more of snow. It's not everywhere. Now, in this December case, we did have a wider range of areas that received 10 inches of snow, or more. But what we're saying here is that, there's some places that there is a small chance that could see more than what we're forecasting. So here's the other products that we have, and this is from a completely different event. In fact, it's from the Northern Virginia, the Sterling forecast area, but it does go to show what the percent chances of 4 inches or more snow, or what the percent chances look like. Instead of giving you the amount of snow, the worst case expected, it actually gives you the percent chance of a certain threshold being exceeded. So in this case, you're looking at a percent chance of 4 inches or more, and you can see up, into Maryland, Westminster, Baltimore, Bel Air, has 40-50% chance of 4 inches or more snow. You get down into here, towards DC and further south, that's where you start to get into that gradient. You could probably, suggest by that there's a lot more uncertainty, and at least for getting that 4 inches of snow in the DC area. But again, that's still a 1 in 3 chance, right? There's a 1 in 3, basically saying that's a 1 in 3 chance that you're going to get 4 inches of snow in DC. Now there's a 1 in 2 chance up in Westminster, so it's definitely a higher probability, higher chance that you're going to get at least 4 inches of snow. But still, that's not something to blow off. I mean, a 1 in 3 chance, a lot of us would probably take a 1 in 3 chance to buy a lottery ticket, or something. So I mean, to win the lottery. So it's just because there's lower probabilities compared to other places on the map doesn't mean that that's not going to occur. So I think that's really important for everyone to understand, is that these are probabilities, and just because an area has a lower probability compared to another area in the state doesn't mean that they still won't see that amount. It's just that according to all the computer models and our data, they just have a lower chance. So I think that's really, really important to realize. Another thing, and this could be really helpful for those of you who are just wanting to know specifically for your town, for your or county, what is the chance of snow accumulation for a specific town. And again, this is for the Sterling's forecast area, but we have the same thing for many locations in our forecast area that you could look at, and is basically a printout of what we're expecting for not only the most likely, but the sort of the min, the low end, the maximum, the high end, what the worst case, and then the various probabilities for certain thresholds, 0, 1, 2, 4, 6, so on and so forth. So again, I think this is very powerful too, if you just quickly want to pull up your town or your locality and figure out what you want to, what are the chances of various snow accumulations. So this is actually the example from December of 2018. I sort of showed a lot of the graphics already, so I'm not going to go into this greatly, but you can see this is the actual observed snowfall. A lot of places over 10 inches, even over 10 inches to a foot of snow in places, and then tapering off rather quickly once you get to east of Richmond, especially towards Williamsburg and closer to the coast. This is from the afternoon, and I basically showed these earlier, but you can see that our official forecast was showing accumulating snow east of Richmond, but the highest amounts were still across the Southern Virginia Piedmont, but I think the important thing to recognize here is that there was the worst case, this 1 in 10 chance that things came together perfectly, and as we know, they did. But if things came together perfectly, that we would have much higher snowfall amounts further further north and also further to the east. But do note here, and this I think this is where this is really important, that these and I really like these probability graphics of 2, 4, 6, 12, whatever. Notice that even though the worst case was 10, 11 inches in Richmond, there was still a 22% chance, or basically 1 in 5 chance, that Richmond was going to see 8 inches or more snow. So to me, that's valuable information for planning purposes. And there was a basically 50-50, 1 in 2 chance that there was going to be 4 inches of snow, or at least 4 inches of snow. So to me, so to me, the for again for every folks that are planning on your actions for snowfall, having this information can be very useful to you, as much as our in a way it can be useful beyond what our official forecast has. Here's another quick prop snow example. This is from back in 2017, where there was a band of snow that a lot of snow in the 6 to 8 inch range, but there was a small band of more than 8 inches, up to a foot, from extending especially from Williamsburg to the East Virginia Eastern Shore. And again, this sort of goes through the evolution of that. Is that this is from a couple days before that. We had the heaviest band initially further south, right into North Carolina, maybe extending into the Southeast Virginia Tidewater. But again, there was some hints in the worst case that there could be some heavier snow shifting further north, right? Especially across into Williamsburg and the peninsula across to the Eastern Shore. But again, the probabilities, again, this was a couple days out. Probabilities were still pretty low because there was still a lot of uncertainty in the models. As you go forward the next day, again, that was from the 4th, this is from the 5th. Notice how everything shifted. First of all, we had more confidence in our forecast that there was going to be heavy snow band developing, across, especially across the peninsula, Southeast Virginia into the Eastern Shore. But the models also showed that increasing probability as well. I mean, look how high the probability of 6 inches is 2 in 3 chance, 60 to 70% chance across this area. Probability of 8 inches was basically 1 in 2 chance, and even the probability of 12 inches. Now, again, this was a little further south. Again, there was still some, even at this point, there was still some uncertainty where the heaviest snow band would set up, but there was still a, basically 1 in 5 chance that there was going to be a foot or more of snow. And then finally, you get to the morning of the 6th, and this is sort of right before the event really started. And look how the probabilities really shot up across the area, showing showing even a 30 to 40%, 30-ish% chance across this area. And notice how the 90th percentile, the worst case scenario, shot up really across the whole area. There was still some uncertainty even at this point if a heavy snow band might be able to set up a little further north, even as far north as Richmond. And remember, if I go back here, and I apologize, remember, ultimately that snow band did shift a little further north than even what we were indicating. It was more from, south side, Richmond Metro, Petersburg, maybe Dinwiddie, up through Prince George and Surrey, and then across the peninsula into the Eastern Shore. So that was right, but not the whole area didn't see that foot of snow, but there was some isolated spots that still saw a foot or more of snow. So I'm not going to, for lack of time, I'm going to skip over some of this stuff, but I think looking at the trends of these can be very helpful too. I'm not going to get into details, but I think looking at trends and seeing where we're showing where the snow bands could set up or where the worst case scenario could be is really important. So I went over all these graphics and you know, now you have information that can show that we're expecting 0 to 14 inches of snow. Well, no, it's not that. It's not a hedge in our forecast. It's, you know, our official forecast is still our best forecast for expected snow amounts. What we are showing is, again, the worst case scenario where if things come together perfectly, you could get these snow amounts, or vice versa, things come together perfectly on the other side, you may not get nearly as much snow. So it's a planning tool. Again, it's really important to note that our official forecast is still our you know, our best forecast for expected snow amounts. And again, where can you find this data? You can find it on the webpage there. You can also find links to the information on our briefing pages. And you know, email myself if you have, or Jeff or Eric. I need to put Eric's name on there as well. But if you have any questions on this information. So with that, I will transition quickly since we're continuing with winter. Is our winter storm outlook for the days 3 through 7. And again, this can be found on our winter weather page. And really what this is a lot to allow you to get a better understanding of what could happen with winter weather impact wise in the extended periods in days 3, 4, 5, 6, and 7. The problem in the past is that we've tried to put this information in, say, a hazardous weather outlook, HWO, and we do. I mean, we'll put it, you know, we'll put information like increasing confidence of snow, and even put some aerial details in. But the fact is, it's a text product, and a lot of times people don't see this. So what we've decided to do is to come up with a map that is run twice a day, that allows us to convey these threats, or potential threats, I should say, in the extended for winter weather. And again, it's a color-coded system. You know, green for nothing, yellow, which, you know, there's a slight risk, you know, for winter storm, you know, threat. Enhanced, which is this orangey color, and then you get into the reds and the purples, which are definitely more, you know, more significant. And we're trying to relate forecast confidence to potential impact, right? So we're, you know, you could have a really high confidence of a storm, but you're unsure about the potential impact. So you would only have maybe an orange, you know, an enhanced risk. Meanwhile, if you're really confident and you really also think there's going to be a really high impact, let's say it's going to be, we're expecting a foot of snow, you're probably going to start seeing these reds and these, even, you know, in the worst case, the purplish colors as well. So, and this is sort of the threat matrix and how the colors relate to what the threats are. It sort of follows the SPC, the Storm Prediction Center model for severe weather, you know, from slight, enhanced, moderate, and high. You know, and you can go over these for specific details, but certainly, you know, slight is something like, you know, there may cause some travel disruptions, to even enhanced as, you know, travel disruptions. And then you get into moderate and high, where you could have significant closures, delays, you know, maybe threats to life and property if you're exposed to the elements, or you know, out on the roads and you get trapped. You know, these are especially for down here, these high and especially high would be extremely rare. Moderate could happen, you know, something like the major snow from 20, I guess, early 2016. You know, the storms from, you know, maybe 2017 across the Tidewater area and Eastern Shore that I showed, and even the Richmond snow from 2018 would probably be at least moderate. I don't know if it'd be high. It'd be close, but certainly would be moderate. And again, you can find this information on our winter weather page, and here's all the probabilistic information tab, which pops up initially. You can just click over to day 3 through 7 winter thread and get that information as well. And again, this information will be updated twice daily. You know, I think it's a good idea if there is a potential winter storm on the horizon to just keep an eye on the graphics and the trends. I mean, we'll normally would start out, especially if it's a week out, you know, maybe a slight threat for winter storm or you know, winter impacts. But as we get closer to the event itself, you want to monitor for changes. You know, it could be worse, could be better. You know, so I think it's good to keep an eye on and watch for the changes upward and downwards. So last but not least, and again, I can take questions at the end. The snow squall warning, I'm going to go through this really fast because these will be very rare, but nonetheless, it's certainly something that could happen. And because you're probably seeing it more, you know, if you talk to your colleagues up in the Northeast, or you know, places that see more snow than we do, you're probably hearing about these things, and a lot of times, especially again, it doesn't happen so often down here, but in the Northeast or northern parts of the country, they will have sudden onsets of heavy snow with, you know, visibility is close to zero, really close to blizzard conditions. Really, it is sort of a mini blizzard, but it only lasts for a half hour or, you know, 45 minutes, you know, a very short period of time. And maybe the snow only accumulates a half inch or, you know, or just, you know, not a lot. But the problem is that when you have a heavy snow squall with visibility is close to zero and temperatures rapidly falling, it can cause a travel nightmare on the roads. And before a couple of years ago, we had no way to really convey this type of hazard, and it is a major hazard. I mean, you've heard about you know, incidents up in especially Pennsylvania and other places of the country where you get this squall line come through, and maybe it's only a half inch of snow, but it causes 80 car pileups, say on I-80 in Pennsylvania or something like that. And so we had no product to convey that, but now we do. It's a snow squall warning, and it's really a product similar to a severe thunderstorm or tornado warning, in that it's a polygon-based product, and it's usually issued only for maybe 60 minutes, 45 minutes for a small area, expecting these conditions. You know, basically heavy bursts of snow that leads to close to or blizzard-like conditions. And it is important to realize that this is something that we're going to issue mainly when the roads are below freezing or close to freezing, causing those rapidly deteriorating road conditions. Because that's the problem, right? You have this snow squall, the road temperatures are 28 degrees, and immediately everything becomes a skating rink, and people can't see. They try to put on their brakes, that's not working, and it just goes, you know, it just goes downhill fast. So that's when they're going to be issued. One time they won't be issued, which maybe is sort of counterintuitive, but when you think about it, it sort of makes sense. We will not issue these when a winter storm warning is ongoing. The reason for that is because the winter storm warning in itself implies that conditions are dangerous and you should be careful. The snow squall warning is really meant to be a short fuse product for something that's going to happen brief, you know, a quick snow squall, a quick whatever, that afterwards the conditions will improve. So again, I get where it could be counterintuitive, but there's an important distinction. I mean, if we have a winter storm warning out already, we're already saying that travel's hazardous, it's dangerous, and to be careful. And people should be aware of that. So here's an example back from 2015. It was actually Valentine's Day of 2015, where if we had this product in our arsenal per se, it's possible we would have issued a snow squall warning for the Richmond Metro. You know, at this point, and this was all snow, by the way. You know, temperatures go, and the time goes from bottom to top here. Look how the temperatures rapidly diminished to at or below freezing. And notice how the winds picked up with gusts to 40, 50, even close to 60 miles an hour at Richmond. And the visibility, although it didn't get down to a quarter mile, it was still, I mean, a half mile. That's, you know, it was really went downhill fast. And so this was at the Richmond airport here. So this is the case, and I don't know what the road temperatures were, but assuming the road temperatures were close to freezing, which they probably would have been pretty quickly, especially with these dew points being so low. They were in the single, you know, teens. They probably would have, the road temperatures probably would have dropped very fast. And plus, it was at night. And this was GMT time, so it was 8, 9 o'clock at night. This is a case where we probably would have issued a snow squall warning for the Richmond Metro and this whole rear area here, just based on that information. And it would have probably looked something like this. Again, a polygon-like thing, you know, sort of like what you would see with a severe thunderstorm warning or something like that. Last but not least, a few notes about the snow squall. Again, I'd want to emphasize it will not be issued during winter storm warnings. Again, normally, if you start hearing about Arctic fronts, you know, and hearing about, you know, potential band of snow with an Arctic front coming through, you know, it's you know, be aware that you might see this product, you might see this come out. Another thing to note too is that you know, there are many, I shouldn't say many times, but there's a lot of times that we see heavy snow with very reduced visibilities with temperatures of 34, 35. In fact, I would argue that's a lot of times that's when we see our heaviest snow, is when snow bands come through with temperatures above freezing or slightly above freezing. We probably would not issue a snow squall warning simply because we wouldn't be expecting the roads to become severely impacted. And you know, we're keeping an eye on the webcams and the, you know, all the VDOT webcams and everything to keep, and also the data from the road sensors to determine that. But and we also have some modeling that helps with that as well. But you know, again, it's something to recognize that just because there's a heavy snow band that might be reducing visibility doesn't mean that we will be issuing a snow squall warning, especially if temperatures are staying, you know, slightly above freezing. So that's all I have.